Hydrocarbons. Chapter Hydrocarbons has two subtopics, 5.1 Alkenes and 5.2 Alkenes. 5.1 Alkenes. Learning outcomes. At the end of the lesson, students should be able to A. Define and classify hydrocarbons into aliphatic and aromatic, saturated and unsaturated. B. Draw structure and name alkene compounds according to IUPAC's rules for straight chain and branch alkanes with parent chains equal to or less than 10 carbon. Cyclic alkenes from 3 carbon to 6 carbon and alkyl groups. Hydrocarbon is a compound which contain only carbon and hydrogen atoms, are classified as aliphatic hydrocarbon and aromatic hydrocarbon, which contain one or more benzene rings. Aliphatic hydrocarbon are alkenes is saturated hydrocarbon because content of carbon-carbon single bond. Number 2, alkenes is unsaturated hydrocarbon because content of carbon-carbon double bond. Number 3, alkynes is unsaturated hydrocarbon because content of carbon-carbon triple bond. Cycloalkane is saturated hydrocarbon because the carbon atoms are joined in the ring and content of carbon-carbon single bond. Cycloalkenes is unsaturated hydrocarbon where the carbon atoms are joined in the ring and contents of carbon-carbon double bond. Saturated hydrocarbons is a compound with carbon-carbon single bond and contain the maximum number of hydrogen atoms that the carbon compound can pose. Example, alkene such as ethene. Cycloalkane such as cyclopropene, cyclobutene, and cyclohexane. Unsaturated hydrocarbons is a compound with multiple bonds. Example, carbon-carbon double bond in alkenes and carbon-carbon triple bond in alkynes. They pose fewer than the maximum number of hydrogen atoms. Example, alkene, which content of carbon-carbon double bond. Aromatic, which content of carbon-carbon double bond in aromatic ring. Cycloalkene, content of carbon-carbon double bond in the ring. And alkyne is content of carbon-carbon triple bond. Alkanes are known as saturated hydrocarbons which contain only single covalent bonds. The general formula for straight chain alkane is CnH2n plus 2, where the n is equal to or greater than 1. General formula for cycloalkanes is CnH2n, where n is equal to or greater than 3. Each carbon atom in alkane is sp3 hybridized carbon atom, tetrahedral with 4 sigma bond, and all the bond angles are close to 109.5 degrees. Alkenes IUPAC names have the ANE suffix. The first 10 unbranched alkanes or straight chain alkanes based on general formula of alkanes CnH2n plus 2 start from 1 carbon. The molecular formula is CH4 until 10 carbon, the molecular formula is C10H22. The number of carbon is 1. The name of alkane is called methane. 2 carbon is called ethene. 3 carbon propane. 4 carbon butane. 5 carbon pentane, 6 carbon hexane, 7 carbon heptane, 8 carbon octane, 9 carbon noctane, 10 carbon decane. This is a 3D molecular shape of alkene, and each carbon atom is a sp3 hybridized carbon atom in tetrahedral shape with 4 sigma bonds. Starting from C4H10 onwards, the alkenes show the phenomenon of chain isomerism. They can exist as linear or branch alkenes. Example, C4H10. The linear alkanes is butane. Structure is CH3, CH2, CH2, CH3. And the one branch alkane is called 2-methyl-propane. The structure here is CH3, CH, CH3 with one branch CH3 group here. Next example to show chain isomerism is C5H12. The first structure is linear alkane from 5 carbon is called bentene. The second structure is one branch alkane is called 2-methyl-protein. The one branch is here, CH3 group. The third structure is two branch alkane is called 2,2-dimethyl-propane with two branch here, CH3 and CH3 here.